Okay, everybody, welcome to Vector Addition. Not exactly my favorite way of doing this, but anyway, we're going to be using the ruler and the protractor a lot, so I figured this is probably the best way. Anyway, let's start. Vector addition, tail to tip. Place the trail of the second vector B at the tip of the first vector A, then draw a line from the tail of vector A to the tip of vector B. This new line will be the resultant vector. So whenever we're adding vectors additionally, what that means, even mathematically, what it means is we're just like we're literally drawing them on top of each other and seeing how that works. Okay, so for example here, this is vector A, and then we have vector B over here. So if we want to see what this vector is plus this vector, what we literally do is we start at a point. Let's say we start at this point right here. We draw one of the vectors. It actually doesn't matter which one. Like just like when you're adding 3 plus 5, if you do 5 plus 3, it's the same. But we first draw, in this case, A. So we draw it out. We're going to see drawing it with a ruler and everything like that. And then we're going to, after that's done, after we draw A, then we're going to find where A ends. And then we're going to draw B. And then wherever you started from to wherever you ended from, that's going to be your resultant vector. Okay? And it's important, like when you are adding vectors graphically, make sure to always make a legend. For example, 1 meter equals 1 centimeter. For example, like if this has like 5 miles, we obviously can't draw this as like a 5-mile vector. But if we say 1 mile is equal to 1 centimeters, now all I have to do is I have to draw out 5 centimeters, okay? For inches or whatever you want to do, okay? All right, so let's move on. Let's see how this is going to work. I'm a little worried. Troubleshooting here. Okay, example number 3. Graphically add the following vectors. Vector A is 10 meters north and vector B is 5 meters east. Personally, what I like to do just right away is I like to just see like a general direction of this. So it's like, okay, this is generally going to go up. This is generally going to the right. And it's like, okay, now that it's going to go up and right, I know that I'm going to start this whole thing somewhere like over here. Maybe I'll put a dot right there. Okay, that's where I'm going to start. Okay, so what I like to do right at the beginning when I start is I like to make cross sections. So I'm going to make a cross section right here. This is from where I'm starting from. And I'm just going to go in the order it says. It doesn't matter the order, but that's what the order I'm going to go. So it says 10 meters north. So first thing I'm going to do is I'm going to say, I'm going to make a legend. 1 centimeter equals 1 meter. Okay? Because, so now I'm just going to go, I'm going 10 centimeters straight up. Ooh, that's pretty high. Maybe I should have started lower. Okay, anyway, here we go. 10 centimeters straight up. There we go. And then at the very tip, I am going to put an arrow. Okay? So this is my vector A. And then what I like to do, I feel it makes things easier, is I'm going to make a cross section right where I ended. This helps me with my next vector. So this is my cross section right where I ended. And now I'm going to draw B, 5 meters east. Okay, I guess I could just do this. I'm going to go from, sorry, I'm like a limited space. So I'm going from 15 to 20 here, but I would just go 5. And I'm just going directly to the right. Okay? And that's where I ended up. This is vector B. So now that I drew A and B, I could add them both up to find the resultant vector. Okay, so what I'm going to do is I'm just going to go from start to finish, from here to here. I'm going to start at that 0 point and end right where it ends, right there. And I'm going to draw it. Oh wait, I should draw in a different color. Sorry. I'm going to draw in a different color. And if you don't draw in a different color, that's totally fine, but I would make this distinct in some kind of way. Maybe making it dotted, maybe making it bold, something that shows that this is the resultant vector. Okay, so somehow making this the resultant vector. And maybe I'm gonna dot it. Nah, it's gonna move the table too much. So anyway, I drew it in red. So somehow distinguish this as the resultant vector. I'm also gonna do like R that. And that's our resultant vector. A plus B equals this resultant vector. And how I know what this is now is I'm just gonna measure it. Go from here to here. And that looks around 11.1, I'm gonna say. That's my estimation. So the resultant vector is equal to 11.1 centimeters. However, 1 centimeter is equal to 1 meter. And remember to put this down because this is part of your answer. 11.1 meters at, and now I have to do an angle. So remember, from the angle, we're going all the way from this starting point to this right here. In this case, this right here. And I'm going to measure that with a protractor. So I'm going to put this right where the cross section is. And then I'm going to see that this is around, it seems like 64 degrees. Okay. So that's my answer. Okay, what you can tell is the actual answer here, if we did it mathematically, which we'll show later on, is 11.18 meters at 63.4 degrees. So pretty close, not exact, and there's just error there with my measurements and different things like that. However, I would say that it would be good to get within 10 to 20%. I guess 20% is maybe too much, 10 to 15% of what the actual is. Okay. Let's move on. So far, so good. Example number 4. Graphically add the following vectors. So now we have 3 of them. Let's just see what the general direction is going to look like. So we're going to go up, then we're going to go to the right, then we're going to go down. This time, like, I ended up all the way up here, so I'm going to start lower. Like, maybe I'm going to put this as my starting point right there. I'm going to make a big cross section right here because this is my starting point. Starting point could be wherever you want, but if usually for this you just need a lot of space. Okay, and then I'm going to go 10 centimeters. Oh, again, 1 centimeter is equal to 1 meter. Made my legend. That legend needs to be there in order for this answer to be correct. And then I'm going straight up 10 centimeters. Sometimes straight up is just hard for me as well. Okay, oops. Sorry. 10 centimeters. So that's vector A. And then I'm going 7, and then I'm drawing cross section here. I just feel like that's helpful to know where to start. You're always starting where the last one ended. So I'm going 10 centimeters to the right. Again, I'm kind of running out of space here, so I'm just going to go from 10 to 17. To the right. Very good. And then this is vector B. And then again, I'm drawing a cross section here. And then 4 centimeters south. 4 meters south, which I'm translating to 4 centimeters. And that's it. The resultant vector, again, should be somehow distinguished. I have the red, but maybe this time, since most of you don't have different colors, I'll show another way you can do it. So I'm just starting here and ending right there. And then what I'm going to do this time is I'm going to make it dotted. So dot. You can make it bolded. I would say dotted and bolded, if you don't have any other colors, is the best option. Okay, so that is my resultant vector. It's where you started from and where you ended from. And let me just calculate or measure how far that is. I'm going to say it's around 9.1, 9.2, 9.25. Oh, and pretty close, 9.22. So resultant vector is equal to 9.25. That's what I'm going to put. Centimeters, which translates to meters, and now I have to use my protractor to find the angle. So remember, we're starting from here, and we're going over here. This one looks to be 40 degrees, right? Yeah, that looks like to be 40 degrees, going from 0 to 40. 49. Ooh, so that's a bit off. Anyway, I did around 40 degrees. 40 what? Yeah, 40 degrees. Okay, moving on. Okay, looking at this example now, we're going down, we're going to the left, and we're going down. So I'm going to be starting like somewhere over here. Okay, so first again, drawing my cross section. Okay, this is where I'm starting, and I am starting 5 centimeters, going up 1 centimeter equals 1 meter, and here we go. Yeah, I don't feel like I'm so good at drawing these cross sections, but I'm not very good at like eyeballing things at all. I've seen some people are just so good at, like, you know, even like cutting with a scissor. Like, I'm horrible at cutting with scissors if I don't have lines. All right, so that's vector A. Went 5 centimeters down. I'm gonna draw a cross section again, so I know kind of where to start. And this might not seem important, but it's gonna be a lot more important, especially for the later on. All right, and I'm going 17. Again, my ruler is my space is a little limited, so I'm going from 27 to just 20. So there we go. Okay. That's vector B. And then I'm going south again for centimeter stuff. Cross section. This is going to be really helpful, even though if it seems unnecessary right now. For the harder stuff, it's going to be really helpful. Harder stuff? Yeah, there's going to be some harder stuff. Vector C. Okay? So now, maybe I should be drawing this a little bigger, but okay. So now I'm going to draw the resultant vector. Again, it should be different somehow. Bolded, dotted, whatever it is, it should somehow be different. I'm going to be doing it in red. There we go. And this is my resultant vector. It's where you start to where you end up. And yeah, it can go through. That doesn't matter. It's just from wherever you started to wherever you ended, a straight line. And that looks like 11.4 centimeters to me. Hey, 11.4. 4 centimeters, which translates to meters at 2. Okay, and so this is a little complicated. The angle that we're looking for, remember, this is the 0 degrees here. And the angle is from here all the way to over there. And you might be wondering, like, how are we going to find that on the protractor? So I'm going to line it up. But what we're going to notice is it doesn't go all the way there. But something I should notice, or should know, is that over here, directly to the other side, is 180 degrees. So if I just find this angle here, I could add 180 and then figure out what the whole thing is. I'll put that right there. Well, I don't think I drew that straight, but anyway, it's what I did. And this looks like it's going to be around like 55-ish. I don't know, 51, 52, 53, 54. No, 53, 51, 52, 53. So I'm going to say 53 degrees. So this is going to be 180 plus 123, 53, which is 133. 233. Okay, 233 degrees. And yeah, pretty close. So a lot better this time than last time. Okay, moving on. All right, so I think we're starting to get a little bit more difficult here. Okay, so what you're gonna notice with this problem is it's the first one with like an angle here, but we're gonna draw this. Again, I'm gonna kind of draw the general direction where it is. This is going to the right, this one's going up, and then this one is going 30 degrees, so it's gonna look something like that. Okay, so let's see if it's going right, up, and to the right. I'm gonna start in this corner as much as possible. Okay, so let me just start right here. I'm gonna just draw a nice big dotted line. Good. And then, okay, so this is where it gets, oh, I guess, for right now, everything is the same, but it's gonna start getting a little bit different. Okay, I'm going from 10 to 18, just because I'm out of space. Okay, that's vector A. Small cross section here, just to know where to start for the next one. 5 meters north, I'm just going up 5. Oh, 5, a B. Oops, sorry, I did not put the legend. It's really important to put the legend. It's the answer is not correct unless you put the legend. And then last one over here. And this is a little bit more where the cross section becomes helpful. Of course, this is where you're starting from. But, okay, so this is a little bit different. So 4 meters at 30 degrees. We're actually going to need the protractor in this instance. So I'm going to go like this. And then I see 30 degrees. Every protractor is a little different. But once you have the spot there, I'm going to just mark right there 30 degrees. So that's the 30 degree mark. I'm just putting a dot there. And I'm going 4 centimeters this case. So what I'm going to be doing is put my ruler. And I'm just going to line it up to where it was. So 4 centimeters is only over here, but I'm just lining it up with this so it goes at the right angle. So here we go. Right there. Okay. And that is vector C. Okay, so now from where I'm starting, all the way over there. Ooh, it's gonna be a little tricky. It's like C is like going in the same direction, so it looks like this angle is gonna be around 30 degrees, but anyway, drawing my resultant vector, again, it should be different somehow, whether bolded or underlined, somehow different. Okay, resultant vector, and let's measure it. Going 13.5-ish, that's what it's looking like, okay. Resultant vector equals 13.5 centimeters, which is meters. At angle, yeah, like I said, it's close to 30, because it's like going in the same direction as C. That's how I knew. And yeah, to me it looks like 32 degrees, so at 32 degrees. All right, moving on. Hopefully this is good, making sense, doing well for you. You're doing well with all of this. Oops. I know some people like really struggle with this part and like think this is dumb and they're like, let me just do the math. And some people like kind of love it. It's like, oh, very practical and understanding. So it's like different. Okay, so this one, A, B, and C, we're going to start. I'm just doing like the general. We're starting to go to the left. And then 120 degrees. So I know 90 is straight up. So then 120 is going to look something like that. And then south like this. Okay, so, I think I'm going to kind of start in the middle over here, but to the right. And then I think that will work. Okay, again, starting with the big cross section. Middle point right there. And then I'm going 1 centimeter equals 1 meter. Okay, I'm gonna start, I'm running out of space here, so I'm gonna start at the 20 and just go to a 6, so 14. 1, 2, 3, 4, 5, 6. Okay. Wish I had more space for doing this, but anyway, Not ideal how it's all going, but should be fine. So this is vector A. And then doing cross section. And this is kind of where the cross, oh, actually you'll see with the next one. So now I'm doing 120 degrees. So I'm putting that here. 120 degrees. So we should know that straight up is 90, then 100, 110, 120. Making a mark right there to guide me for the next part. I'm going 7 centimeters in that direction. It doesn't reach, so I'm just going to start at this 10 and going to end at that 3 point. Okay. There we go. That's my vector B. And then, okay, and I think it's really important to make the cross section, especially after these angled ones, because you could be like, oh, where's south? Is it like that way? No, south is always directly down, west is always directly to the left, and everything like that. So making a cross section after the ones that are angled, I feel like will make sure that you don't mess up stuff like this. All right, and then I'm going 8 centimeters down. Okay. And that's C. And we're finding the result vector from where we started all the way to where we ended. Okay, so let me get my red. Where's my red? There you are. All right, let me draw it first. Don't like the, oops, sorry. Don't like the angle of all this, but I mean, my working station, but here we go. Probably tired of me hearing that. Okay, that's my resultant vector. Let me see if I can find what it is. No, it's going directly on it, so I'm just going to go from the 30 to what I'm going to call 20.3. 30 minus 20.3. It's a little too early for me to just do this now. 30 minus 20.3. Okay, what is that? That's 9.7. Okay, 9.7. Is that right? 30 to 20.4. All right, 20.4. So that's going to be 9.6. It's a bit off for one reason or another, but it's pretty close still. Resultant vector equal, I'm going to say 9.6 centimeters, which is meters. And at the angle, so again, we're starting from this 0 angle, and we're trying to go all the way through here. Again, the problem that we face is that we don't go all the way there. However, we know all the way to the other side is 180 degrees. And then now we could just measure this part to add to that. Okay, so putting this here, and then we know that's going to be around 12-ish degrees. Okay, so that's around 12-ish degrees. 0 to 10, and then 12. So then 12 plus 180, and this should be 192 degrees. Oh, yeah, seems like I had my SK a little bit wrong. That should be 192-ish, 0.16. Okay, and that's that. Moving on. Okay, so let's look at this. You're looking for a treasure chest. A friend tells you to walk 5 miles north. I'm going to draw that. 5 miles. You're going to start out going that. 2 miles west. Okay, going 2 miles that way. And lastly, 4 miles at 150 degrees. So we know 90 straight up, 180 is directly to the left. So 150 is going to be something like this. Explain graphically how to get to the treasure chest from where you started. I'm going to start in this corner here because it looks like we're going to go up, left, and that way. So I'm drawing right here. And I really need to start with my legend. Okay. Legend is 1 centimeter equals 1 mile. Okay. So let's start this. explain graphically how to get to the treasure from where you started. So I'm going to draw this graphically. I'm going 5 miles up, which translates to 5 centimeters. Nice. It doesn't say vector A, but I am going to label it vector A because that's what we're used to. And then 2 miles to the west, I'm going to start at 20 and go to 18. Boom. Vector B, cross section. 4 miles at 150 degrees. Put that right there. So we have 90, 100, 110, 120, 130, 140, 150. Right there. Everyone's protractor is going to look a little bit different, but you know, how it's set up, how to understand it is always the same. And we're going 4 miles. So I'm going to start at 30 and go to 26. Line it up. Boom. Call that vector C. Remember, our resultant vector is wherever we started to wherever we ended. So let me just draw it out with my red. It needs to look a little bit different. Okay, that's my resultant vector. Okay, now let's draw, see what this is. A little annoying, okay, ended right there. So this looks like it's almost exactly 9. I'm gonna put 9, okay, 9 miles. Resultant vector equals 9 miles at, and this angle here, there's a few ways I could do this angle. Essentially, I'm looking from here to all the way over here. So 2 things I could do. I could put that in my protractor and see, or I can measure this angle here and then just add it to the 90 here. So whichever way, it's going to give you the same answer. So let's see, I'm putting this here. My protractor is set up in a way where it makes it easy. So 90, and then it's going to be close to 130. It's going to be 128. Yep. Okay, 128. Yep. At 128 degrees. All right, I think we have one more left. Last one here. Looks a little bit different, but hopefully is totally fine. Example number 9, graphically add the following vectors. Find what A plus B is. So we know A is equal to 4.5 and it's at some angle like this, 30 degrees. And B is 6 and at some kind of angle like this, 60 degrees. So anyway, I know how it looks like already. I'm probably going to start like in the middle here and then just go like that. There doesn't need to be a legend because this isn't in centimeters or any kind of units. So I'm just going to get started. Just draw my cross section. We have 2 angles here, so this is a bit more complicated. So 30, this one is from the 0 degree part, it's just going 30 degrees up. So that's just what I'm going to do. From right here, I'm going 30. Oh man, I'm really not straight. Especially when I line it up to this thing that shows me how straight it should be. It should be something like this. 30 degrees right there. Great. I'm going to draw this. Oh, what am I doing going all the way over there? I'm only going to go 4.5. So right here. So that's my vector A. Okay. You know, I was just thinking in my head, oh wow, I haven't used the eraser. I should have just used everything in pen so it looks more clearly. And then that's what I'm doing. That's the mistake I make as I'm thinking that. Okay, and then during cross section, again, really important, especially when we're doing the next angle here. So this next angle, it says 60 degrees right here, but it's a little deceiving. How to understand this? This is 0 degrees, and it's going all the way over here, which is, you know, the whole thing is 360, But if this is 60, it's going to be 360 minus 60. So this whole thing is 300 degrees. Or two ways we could think about this. This angle here is 60 degrees, so I could just kind of flip this backwards and do 60 degrees. Or I could think about it from this place, and this part is 30 degrees, because 30 plus 60 is 90, and this whole thing is 90. So I'm just going to flip this over, and then I'm going to go 60 from here. So 0, 10, 20, 30, 40, 50, 60. Make a little mark right there. And then I'm going to go 6 down. Let me see, this way. Boom. So that's vector B. And now let's add this up by finding the resultant vector A. Not an optimal point for me, but I'm going from 10 to whatever. So starting at 10. Okay, there we go. And to me, that looks like 17.4. Huh? What happened over here? Oh, 10 to 17.4. So that's 7.4. Okay, so resultant vector here is equal to 7.4 at, and remember the angle that we want, we're going from this 0 degrees all the way over here. A few ways we can do this, but I should know, I guess I should know over here is 180 degrees, and then I could add this up, or I should know that this is 270 degrees, and then I could just see what this angle here is. I'm going to kind of go the 180 degrees way, so this is 180, and then to 90, that's 270, and then I get 280. Oh, sorry. So this is 270 degrees. Then it's going to be 280, 290, 300, 310, 320, 330, 335, 336, 337. So I'm going to do 337 degrees. Okay, so pretty close. Another way we could have done it is we could have just measured what this angle is from here to here. So that's going to be 0, 10, 20, 20, 28-ish. No, 23-ish. And then I could do, okay, if this is 23 degrees, the whole thing is 360. So 360 minus 23, and then we get 337. So a few ways to do this, but we have to try to find the angle, starting from this 0 degree part all the way to here, one way or another. All right, guys, thanks for watching. Hopefully don't have to do something like this again, but hope you enjoyed. I'll see you for the next one. Bye.